Man, so it's ChemTalk. It's ChemTalk on TikTok. We're gonna do a quick chem task so that you can figure out how to make Lewis structures, molecular structures, how to show the atoms and their connections with each other. That's what we're about to get into. So get some pen, get a pencil, some paper. Don't play with me. Get your notebook ready because you need to write down what we're about to do. It's important. Let's get to it. I want you to understand. We got valence electrons. Those are the dots. And we have 2 electrons is equal to 1 connection, 1 bond between 2 atoms. So if I see a single line between 2 atoms, that is telling me that there are 2 electrons being shared between these 2 atoms. That's how they are staying connected. Are y'all with me? All right. So we got our valence electron count. We know that there's 6 valence electrons in sulfur. So we place these dots around sulfur, 2 per side, until we end up with all of the valence electrons surrounding the symbol. 6 valence electrons, 6 dots surrounding the symbol. That's just for the element. That's just for one atom, but one atom is going to connect to another atom. So we need to know how to draw these structures when there are multiple atoms. And that's what we got these steps for, okay? So we got steps. The first step is going to be to arrange the atoms in a lowercase t. A lowercase t. So to do that, I want you to think of dotted lines now. Dotted lines. We're going to do a lowercase t. We got 5 potential locations for these atoms in this shape. Are you with me? 5 potential locations. The first one is the intersection of that T. Boom. This, we call it the central atom. Then you got on every end of that T, the 4 sides, we got terminal atoms. Those are the atoms on the end. So the most that you're going to have to do in high school is you're going to have to do a Lewis structure that has 5 atoms in it. Those 5 atoms, one of them would be placed here, the other ones would be placed there. But let's go back to the steps. Step 1, arrange our atoms in the T shape. Step 2, you have to count the total number of valence electrons. We just said the valence electrons are what are being used to make the connection. So we got to count how many of those connections are we going to be able to have? How many of those electrons can we use to make connections? So we got to count the total number. The step 3, once we have our atoms arranged, we got our electrons counted, we are going to put a pair. That's where kids get it wrong now. Make sure you pay attention to this part. We put a pair of electrons between our center atom and our outside atom. So if that's our center, we got a pair here, pair here, pair here, pair there. That's step 3. Only 2 more steps to go. It's quick. Try to make it quick. Step 4, we are going to keep track of the electrons that we have been placed. Let me take us back for a second. Step 2, we had to find those electrons. How many? Step 3, we're going to start placing those electrons places. And as we do that, we keep track. You got to keep track. If I got 30 electrons available to connect, I need to see 30 electrons either connected or around this molecule. So step 4, place the remaining pairs of electrons around all of your outside atoms. And of course, hydrogen, don't forget, that's the X factor right there. He does what he wants. Out of the 118 elements, hydrogen's the only one that's cool with 2. Every other element wants, remember our octet rule? 8 electrons around them. So we're going to place the remaining electrons in pairs around the outside atoms because we already have electrons between the inside and the outside atoms. The final step, we got to make sure every single atom, including our inside atom, the central one, has that special number, 8 valence electrons around it. the octet. All right? These are rules. One shot. You ain't playing. You with me? Yes, sir. So CF4 is an example problem. We have 1 carbon and 4 fluorines. So step 1, arrange them into our shape. Now out of our carbon, 1 carbon and 4 fluorines, which one do you think goes into the center? That's right, the carbon. So we're going to put our carbon here. We're going to put our fluorine, our fluorine, our fluorine, and our fluorine. Remember, we got our T shape, yes? Got our T shape. Don't forget it. Second step is going to be to count the total number of valence electrons. We have 1 carbon. Carbon's in group 14. We got 4 valences. We got 4 fluorines. Fluorines in group 17. We got 7 valences for a total of 32 valences that we have to show either with dots or with lines being connected amongst these 5 different atoms. Right? Going back to our step 1 and our step 2. Got them set. Step 3, place a pair of electrons between center and outside atoms. Our electrons, a pair of electrons can be represented, don't forget, by a single line, single bond. So that's telling us that we now have had 2 electrons, carbon and fluorine, 2 here, 2 there, 2 there. So we have used up at this point 2, 4, 6, 8 valence electrons. And like I said, this is key, y'all. This is very key. Keep track of these electrons. Now I know after setting up my skeleton, I got 24 electrons I need to show. Step 4, put the remaining electrons around the outside atoms so that they have an octet. Every fluorine has 2 valence electrons being shared with it at the moment. So if I put 6 on each one, I end up using all 24. My final step, check to make sure every atom has 8 electrons around it. So we got 8 valence electrons around each fluorine based on how we set this up. The last step is to check the center atom. If we check the central and it has 8, we're good to go, we're done. Central, we got 2, 4, 6, 8, because remember every line represents 2 electrons. That one's good to go. That molecule, there's your Lewis structure. We know exactly how those atoms are connected and where the lone pairs of electrons are located. That's important for the next thing after Lewis structures. Another example that'll help you understand step number 5, CO2. CO2 has 1 carbon, 4 valences. It has 2 oxygens, would have 6 valences. So a total of 16 electrons got to be shown. I got to show all 16 of these and how they are used in this bond, in this connection of CO2, which has 2 connections. But so we arrange it because we don't have 5 atoms. We don't have to fill up these 2 locations at the top and the bottom. We'll just stay right on the straight line and they make it nice and easy. Carbon in the middle, oxygen on the outside. Steps 1 and 2 are done. Step 3, place a pair of electrons between the central and the outside atoms, each of them. How many electrons does that mean I'm about to use? 4 more. And don't forget, we got to keep track. So we got -4, 12 left. Each of these oxygens, because they already have our 2 being shared with carbon, are going to get 6 more each, which means I've used up all 12 of my valence electrons, all of them that are there. When I check my oxygens, I see that oxygen has 8 electrons each. When I look at carbon, though, carbon only has 2, 4. So part of number 5, if your central atom doesn't have enough, you need to move pairs of electrons, pairs, from the outside atoms into the middle so that they can then be shared and give carbon enough that it needs. So if I do that here, I move those from there, atom there, I now have still 8 for oxygen. Carbon has 2, 4, 6 now. I'm getting closer. So what do you think we do next? That's right. We're going to do the same thing with the other side. So we're going to take those away and move them into there. And now carbon 2468 and our oxygens 2468. They got their octet rule, and we know how to do Lewis structures. So follow your steps. Count your valence electrons. Keep count. Remember, 2 electrons per line. Follow your steps, and you're going to be able to do Lewis structures of any compound I give you. Peace. Have a good one.